Good morning, guys. Okay, morning, guys. Let us get started. Yeah, morning, Bhaskar. So, हम आज फुल वेव कन्वर्टर के बारे में डिस्कस करें। कल क्या हम आउटपुट में एक ही पल्स आया, आपने देखा होगा, एक पल्स इज जनरेटेड आउटपुट में विथिन ए टाइम पीरियड of 2 pi. Now we'll see the 2 pulse converter. Two pulse converter, or we'll say this single phase full wave converter. Single phase full wave converter. So first I'll take the resistance load. There are two varieties here now. Something called a bridge converter. आप पीडीसी में देखा है, लेकिन वो कंट्रोल्ड नहीं है, वो डायोड यूज कर दिया तो अनकंट्रोल्ड हो जाएगा। लेकिन इधर कंट्रोल है ना, सो मतलब now the 4 SCRs are taken. I'll take the resistance load. This is R. इसका बीच में V0 है, T1, T2, T3, T4 ये वाला, ठीक है। So supply, there is supply line and neutral single phase supply, okay. Same we have something called as a midpoint converter with a transformer. The principle is same, and output waveforms are same, but what is the difference here? इसमें तो 4 SCRs यूज करना, इसमें 2 ACR यूज करना, और पीक इनवर्स वोल्टेज पे अलग हो जाएगा. What is midpoint converter? ट्रांसफार्मर लेना है, इसमें 2 ACRs है प्लस, midpoint somewhere here, you connect a load. You can say here now R load. RL load को देखना है. So T1, T2. So and this is I0 and this is V0. So let us see the operation here now. Careful. For example, ये वाला AC supply है, तो प्लस माइनस हुआ तो इधर प्लस माइनस हुआ तो क्या होगा? So I'm just trying to draw here. Supply voltage draw कर रहा मैंने. So once you understand the things, जो भी नेटवर्क ले लो उसको ड्रॉ कर सकते हैं आपने. You should be capable of drawing the things on yourself. So V0. For example, I have given this firing signal is here now. This is your alpha. Alpha क्या करना है इधर देखो. Alpha पहले इधर please mute yourself. I'll do that. Okay. V0 पहले ये देख लो. So 0 to alpha, T1, T2 are forward blocking mode. तो voltage नहीं आएगा. That's what I'm saying. Omega T 0 to alpha, T1, T2 are forward blocking mode. You understand this point? ये वाला समझ में आ गया आपको? क्योंकि फॉरवर्ड बायस में है T1 T2 फॉरवर्ड बायस में है, लेकिन सिग्नल नहीं दिया, SCR को गेट सिग्नल देना है तभी चालू होगा। T3 T4 for इसे रिवर्स बायस है, T3 T4 or in reverse bias, because minus sign is given to the T3, and here now you can see T3 T4. So now ये दोनों बंद हो गया, ये वाला फॉरवर्ड बायस है फिर भी बंद हो गया क्योंकि गेट सिग्नल नहीं दिया। So V0 कितना है? All switches are kind of open, so you don't get any voltage. Are you clear this point? Okay, let me draw here. All switches are open. This is what we have. This is T1 plus minus here now. करंट नहीं जा रहे, so इसका बीच में V0 voltage 0 है. Do you understand this point? T1, T2, T3, T4, all four are open in 0 to alpha. So voltage is 0, then alpha to pi. What is happening into alpha to pi? Next one. Omega t alpha to pi resistive load है ना, T1 T2 फॉरवर्ड ब्लॉकिंग मोड में पहले, तो अभी सिग्नल दे रहा हूँ, गेट सिग्नल दे रहा हूँ एट अल्फा. So what will happen here now? T1 T2 कंडक्शन में जाएगा, T3 T4 are still in reverse blocking or reverse bias. So now, so I'll get this voltage, the same voltage, I'm checking the same repeat voltage. So let me show that to you. ये वाला period में what is happening here now? Let me show. It's space, so just erasing this. So T1 T2 conduction में first to circuit I am showing, I am drawing these pictures. ये वाला बाद में we can directly draw it. Need not draw this one like this. Every time it's a time consuming task. T3 T4. So मैं ये बोल रहा हूँ कि अभी T1 T2 चालू हो गया conduction. So I'm just closing this. So T3 T4 in still open. Reverse bias. So how the current is going? So ये वाला plus है ना, minus है. So इधर क्या IS का direction है? You can say this is IS. So current is going, this is IS to T1 and will come, it is open to the load. So I0 is here now, we'll go to this, then where is that? Either open है, T2 है ना, T2. So T1 से अंदर जाएगा, लोड को जाएगा, T2 में वापस आ जाएगा. That is how it conducts. This is what I'm drawing here now. So that's all. And V0, if you write the KVL, V0 equal to Vs. This is Vs है ना, जो भी voltage है, that's a Vs here now. Next T3 T4 is forward biased at pi. Pi में forward bias हो गया, ठीक है. But ये वाला critical point है, please understand. Pi to pi plus alpha T1 T2 reverse blocking mode है, conduction is stopped क्योंकि natural commutation. रिवर्स बायस में अगर नेगेटिव माइनस साइन है इधर, तो ये बंद हो जाएगा, ये भी बंद होगा. T3 T4 in forward blocking mode. So means same as this one, all four switches are open. So you don't see, this is your alpha, Here अभी alpha दे रहा हूँ किसको? This is alpha for T3, T4. This is alpha for T1, T2. This is the alpha for T1, T2. Alpha for T3, T4. क्योंकि T3, T4 forward bias में इधर आ गए. So what will happen? Pi to alpha, pi to pi plus alpha. There is no conduction. So now between pi plus alpha, so I need that pi plus alpha to omega to pi. T1, T2 is reverse biased only, reverse blocking mode. T3, T4 forward conduction, meaning conduction mode. So then what will happen? The same waveform. Look at here now, same waveform में क्या होगा? ये वाला negative direction है, क्योंकि ये minus आएगा. This is minus and plus. So this becomes your minus of that source, or I can show this way. That's all. Again, you trigger this alpha. This is alpha for T1, T2. Again, this is alpha for T3, T4. So this is how it will be continuous. I hope you understand this point. So conduction कौन चल रही है? Conduction इधर किसका वजह से? T1, T2, T3, T4, and of course here T1, T2, and then T3, T4. So it's keep on, it's going like that. And I naught also same direction. जब resistance load होगा, I naught का, this will be the case. Now the average voltage now, V naught. Bridge converter में भी वही scenario. Bridge converter में क्या चलेगा? When this plus, same thing, plus minus. So इधर plus आएगा, minus आएगा. So T1 चालू होगा. So V naught, which is equal to same Vs. So whatever midpoint means, either Vs होगा, either Vs होगा, either Vs होगा. That's the scenario. This is plus, this is minus. So T1 is reverse bias, T2 is reverse bias when T1 is on. Similarly, minus and plus, minus plus होगा, ये बंद होगा, ये चालू होगा. So again the direction is V naught here. Only problem with this midpoint converter is peak inverse voltage is 2Vm, and the peak inverse voltage for this SCR is Vm. That is the only scenario. क्योंकि peak inverse voltage means when this is off, ये दोनों voltage इसका बीच में आएगा. Anyway, so let me see here now. Average voltage V naught. Now see here now, repetition of waveform. Time period क्या हो गया? This is the waveform repeating. इधर तक है. So 1 by pi integral alpha to pi Vm sin omega t d omega t. I hope you understand this point. So this is Vm by pi sin omega t minus cos omega t alpha to pi. Substitute करो. So this is 1 plus cos alpha. So V naught or RMS voltage, you can keep it the same thing. We can have, I'm just directly writing the value. We know we have done this. Vm by root 2 pi. So pi minus alpha 1 by 2 sin alpha and under root. Okay. Yeah, as I mentioned, please copy this one. Peak inverse voltage for midpoint converter 2 Vm. And bridge converter Vm. Okay. Yeah, by the way, I told you already circuit turn off time. What is circuit turn off time here now? for this one, उसके लिए VT draw करना है. So how much period? VT1 or T1 or T2 is reverse bias, or T3 or T4, anything. T1 reverse bias है, T2 reverse bias, T3 or T4. कितना टाइम पीरियड के लिए रिवर्स बायस हो गया? देखा इधर 0 to pi T1 T2, 0 to pi T1 T2 फॉरवर्ड ब्लॉकिंग मोड, T3 T4 रिवर्स बायस है, अल्फा टू पाई आल्सो T1 T2 कंडक्शन, T3 T4 रिवर्स बायस है. Similarly here देखो pi to pi plus alpha, 1 is reverse bias, 1 and 2, pi plus alpha 2 pi, T1 is reverse bias. So total time period is pi. So omega T is equal to pi, circuit turn of time. This is the one, Tc equal to pi by omega. Okay. Next one, RL load, very important one. See what is happening in the RL load. Now, इसमें problem क्या है यार? Current is not continuous. Meaning, you can see here now. I'll draw the current also because I'm interested in the current portion also. I told you same as V0. Yes, that's true only. Yeah, you can draw the I0 same as this one, but yeah, this is the same shape. क्योंकि resistance है ना, resistance में same shape होगा. So current is discontinuous. Machines में हम देखा है current is discontinuous हो तो क्या problem का है? Torque is proportional to phi Ia. So current zero हो तो दिक्कत क्या है? Torque zero हो. Torque zero हो तो क्या हो गया? मोटर नहीं रोटेट होगा. On and off मतलब अगर फैन को कंटिन्यूसली पुश कर दिया तो कंटिन्यूसली रोटेट होगा. फैन को ऑफ कर रहे, ऑन कर रहे, ऑफ कर रहे, ऑन कर रहे तो क्या हो गया? That won't rotate properly. So intermittently it gets stops when Ia equal to 0. इसलिए current has to be continuous always. You please write a note here now. Output current should be always continuous. Yeah, sorry, some disconnect हो गया, network का issue. So can you hear me now, guys? Can you hear me?
Yes, sir.
Okay, fine, thank you. So what I was saying is current वो वाला ना discontinuous हो गया, ठीक है? So I think you were writing some point that point. So current is discontinuous. We always should maintain the continuous current. So if current is, you write that point. If current is discontinuous, torque will be discontinuous on the DC motor. Mention that point. If current is discontinuous, torque is discontinuous. So let us see now RL load. तो हमारा प्रॉब्लम क्या है, करंट डिसकंटिन्यूस है अगर रेसिस्टेंस लोड इज कर दिया तो, मतलब रेसिस्टेंस लोड मतलब क्या है यार, एसी टू डीसी कन्वर्टर है, डीसी में लोड मतलब लोड साइड में आपका मोबाइल चार्जर रख सकते हैं, आपका डीसी मोटर रख सकते हैं, आपका बैटरी भी रख सकते हैं, राइट? सो राइट साइड ऑन द लोड साइड डिफरेंट थिंग्स वी हैव. अगर मान लो आपने आरएल लोड वाला रख दिया तो क्या होगा? सो नाउ सिंगल फेज कन्वर्टर, फुल कन्वर्टर, 2 पल्स, मतलब 2 पाई में 2 पल्स आया, देखा आपने? 2 पल्स में 2 पाई आया, 2 पाई में 2 पल्स आया इधर. सिंगल फेज फुल कन्वर्टर, आरएल लोड. सो इंडक्टेंस, एक्सटिंक्शन एंगल कितना होगा? इंडक्टेंस आ गया तो करंट पाई से भी ज्यादा जाएगा. प्रीवियस केस में क्या है, करंट विल गो अप टू पाई ओनली. सो लेट मी शो हियर नाउ फर्स्ट ऑफ ऑल. From now onwards, we'll use an is bridge converter. So you are giving supply. No, same thing. Only thing is inductive load रखा है बस. T1, T2 same. So let me draw the supply voltage. This is pi, 2 pi. V naught. So alpha. So for this one, this is alpha. T1, T2 के लिए, that's what I will say. T1, T2 is triggered here now. And T2, T3, T4 is triggered here now. T3, T4 alpha. क्योंकि you cannot trigger at this alpha. अगर मान लो ओमेगा टी देख लिया तो अल्फा मान लो 30 डिग्री है. सो 30 डिग्री में T1, T2 को ट्रिगर कर दिया. T3, T4 को ये वाला 30 प्लस पाई 180 प्लस 30 210 पे ओमेगा टी 210 पे ट्रिगर कर दिया. आई होप यू अंडरस्टैंड दैट पॉइंट. सो हियर अल्फा 30 डिग्री फॉर T1, T2 ट्रिगरिंग, कंटिन्यूसली ट्रिगरिंग करना है. इधर अल्फा आ गया, T3, T4 को ट्रिगर करना है. Yeah. Now what will happen here now? When alpha is triggered, current is continuously going up to what? ये वाला इंडक्टर रखा ना. So T1, T2 omega t 0 to alpha. I'll come to that point. What I'll come back again 0 to alpha के लिए. First hold on. Normally क्या T3 T4 is still in conduction. Why I'll tell you. T3 T4 still in conduction. T1 T2 is in forward blocking mode. Now I'll start from alpha so that you'll have. I'll tell you why that is. Omega t alpha to pi plus alpha or pi. You consider pi only. T1 ट्रिगर कर दिया. T1 T2 को मैंने बता रहा था T1 T2 चालू होगा, ये बंद हो जाएगा. So voltage is across this one is Vs. Previous case में क्या है? Please understand carefully. Previous case में pi तक की ड्रॉ कर दिया मैंने voltage. Do you remember that? V0 equal to Vs. I drawn up to only pi. But now what is happening is even next trigger cycle trigger करके मतलब T3 T4 को pi plus alpha के बाद ट्रिगर कर रहा हूँ या फिर pi plus alpha पे ट्रिगर कर रहा हूँ. उधर तक आपका करंट कंटिन्यूस है. RL लोड है ना, RL लोड हुआ मतलब करंट कंटिन्यूस है. T1 T2 में कंटिन्यूसली करंट जा रहा था. Look at here now what is happening. pi plus alpha तक T1 T2. So this is T1 and T2. ये वाला critical point है. So this is Vs. What is happening is, that's what I am saying, current is going always to this. This is the direction. And V0 which is equal to Vs. Vs का voltage. KVL डालो बस. इसका बीच में only line wire से बस. Only load and source are there. Only point you need to understand is what is that pi to pi plus alpha में क्या चल रहा है. अरे pi में T1 T2 नेगेटिव हो रही मतलब सप्लाई नेगेटिव हो रहा है, माइनस प्लस हो रही, माइनस T1 को कनेक्ट कर दिया तो ये बंद होना चाहिए. ये बंद नहीं होगा क्योंकि इसमें ये वाला SCR में एनोड करंट लेस देन होल्डिंग करंट नहीं हो रहा है. दैट इज द सिनेरियो है ना. इंडक्टर में हमने देखा है only if inductor is taken. Look at here now, one SCR complete inductor is taken here. Now what we have observed? We have observed here now, this is Vs, V0. V0 is sine waveform which is Vs. pi के बाद भी conduction में जा रहे. That's what I told you, beta is 360 degree for inductor. समझ गए ना बात? 360. इसलिए इंडक्टर रखा है तो करंट, it makes the current to continuous. T1 T2 is बंद कर दो. Mute Bhaskar, can you mute? I don't know, I don't have control here. Okay. So meaning T1 T2 will conduct until T3 T4 is triggered. That is a critical point here. Previous case में क्या है? T1 T2 will conduct up to pi only when resistance load is there. Now T1 T2 ये वाला T1 T2 है ना, T1 T2 conduction में जाएगा until the next set of SCRs are triggered. Next set of SCRs क्या है? T3 T4 है. T3 to T4 कहाँ पे ट्रिगर कर रहे हैं इसको? कहाँ पे ट्रिगर कर रहे हैं? pi plus alpha पे. इसलिए T1 T2 कंडक्शन में होना चाहिए. कहाँ तक? pi plus alpha तक कंडक्शन में जाना चाहिए. लेकिन pi to pi plus alpha इसका वोल्टेज नेगेटिव है. This is the one. So this is conduction T1 T2 only. Next point. 2 pi. And now this is what I was saying. Pi plus alpha to omega t 2 pi plus alpha. Next trigger करने के बाद So in this case क्या है, T1 T2 on, T3 T4 off. ये वाला केस में 1 and 2 are off, T3 T4 on. So now same thing, current. But what IS direction is this, but actual current कैसे जा रहा है? Look at here, ये वाला plus हो गया ना, ये this is plus. So actual current is going this way. V naught is same, positive only. But the current IS current is going in opposite direction. You can see here. So representation of IS is plus to minus, left to right. So now IS also get changed, opposite direction में. इससे पहले भी IS opposite direction में, pi plus to 2 pi plus alpha में, और pi plus 2 2 pi पे. Anyway, V naught का वैल्यू सेम सोर्स वोल्टेज आएगा. And 2 pi plus the alpha. So कौन है कंडक्शन इधर? This is T3 T4. Here also T3 T4. So ये क्या है? 2 pi plus alpha है. 2 pi means 0, 360 degree. 0 to alpha कौन कंडक्शन कर रहा है? ये वाला 2 pi है, 2 pi plus alpha है. 0 to alpha कौन कंडक्शन कर रहा है? T3 T4. इसलिए मैंने बता दिया T3 T4 कंडक्शन में जा रहा था. T1 T2 forward blocking. So I need to finish this. So this is what happening here now. So this is what your count conduction है, T3 T4. I hope you understand this point. So please mention this point. In this case, only one point I would like to mention. T1 T2 will conduct, T1 T2 will conduct until next set of SCRs are triggered. T1 T2 will conduct until next set of SCRs are triggered. That is here it conducts from alpha to pi plus alpha, alpha to pi plus alpha. Okay, and that is pi plus, at pi plus alpha, at pi plus alpha, T3 T4 are triggered. At pi plus alpha, T3 T4 are triggered. One second. Okay, just copy this waveform. Somehow this is not recording. Just copy this. कॉपी कर दिया? So इसका सर्क्यूट टर्न ऑफ टाइम क्या होगा? I just need to look in the circuit turn off time. So how much period, either the T1 or T2 or T3, T4 or reverse biased. So you can see here now, they got T1, T2 is conducting from say alpha to pi plus alpha. So बाकी period है ना 2 pi period में alpha to pi plus alpha है, बाकी period कितना है pi. So circuit turn off time is TC is 0 to alpha forward blocking mode for T1, alpha to pi for alpha to pi plus alpha conduction mode. So either the conduction mode mein. So what is left here now? So left of pi minus alpha. So omega TC is pi minus alpha. TC is pi minus alpha by omega. And now we know average voltage. We calculate the average voltage now. Average output voltage. This is the waveform repeating. So what is the time period? इसका time period कितना है? 1 by pi. You can take alpha to pi plus alpha. Wave that is repeating. Alpha to pi plus alpha. Vm sin omega t. So if you do this one, it's a standard one. Vm by pi. Then sin omega t minus cos omega substitute करो. Two cos alpha. Just substitute कर रहा हूँ बस. Otherwise you can do it. Vm by pi minus cos omega t. Pi plus alpha and alpha. So this will be 2Vm by cos alpha. So very important expression. Single phase RL load में 2Vm by cos alpha. ठीक है? Just copy this. I'll ask to record it. Record नहीं कर रहा. ओके या तो रिकॉर्डिंग नहीं हो रहा था, सो पहले पता नहीं, अभी हो रहा है, अभी चालू हो गया। ओके सुनाओ, लेकिन प्रॉब्लम क्या है इधर, मतलब वोल्टेज नीचे जा रही है। टेल मी नाउ वन पॉइंट फॉर मी, is this advantageous output voltage to go negative? One second. कौन सर? हाँ सर जी बोलिए। हाँ हेलो। सॉरी यार, सो मैं ये पूछ रहा हूँ कि इधर वोल्टेज, ये तो करंट कंटिन्यूस है, लेट मी ड्रॉ द करंट, करंट कैसे कंटिन्यूस हो गया, लेट मी ड्रॉ द करंट वेव फॉर्म आल्सो सो दैट यू विल अप्रिशिएट दैट पॉइंट। करंट कैसे कंटिन्यूस हो गया, ताकि टॉर्क कंटिन्यूस होगा आपको। सो आई नॉट है, आई एम इंटरेस्टेड इन आई नॉट। ठीक है, पहले मैं अल्फा से चालू करता हूँ, क्योंकि अल्फा से T1 T2 होगा, that is my intention. Then I'll come back to 0 to alpha. Alpha, this is pi plus alpha, and this one is 2 pi plus alpha conduction. So now alpha to pi plus alpha, कौन चालू है, कौन conduction में T1 T2. So there is no current, is not kind of going down, when current is not becoming zero. So the shape is something like this, pi plus alpha, क्योंकि इंडक्टर है ना, इंडक्टर रिलीज कर रहे हैं एनर्जी। Next now pi plus alpha to 2 pi plus alpha. So who is the guy conducting? Zero nahi hua. And again 2 pi plus alpha. So from here you can see this is 2 pi. 2 pi plus alpha, again it goes. So 2 pi to 2 pi plus alpha. How is the current? Current has to, I'm just coming back here. The 2 pi and 2 pi is nothing but 0. So 0 to alpha, this is the waveform. So look at here now. The current is continuous here now and positive always. I naught ka current always in this direction hai. Lekin source current is in opposite direction. Source current is kind of alpha to pi plus alpha ek direction mein. If you draw the source current, yes, let me draw a source current, IS. So see here now, alpha to pi plus alpha. This is the direction going. T1 to load and T2. Lekin pi plus alpha to 2 pi plus alpha. So when this minus and plus, if this is minus and this plus and minus, so what will happen? T3 current, load current, ये वाला current है, ठीक है, and T4 and the source current is in opposite direction. This is how the source current. समझ गया? So let me draw that source current. So the same thing, I not equal to IS only, but in opposite direction, pi plus to 2 pi plus alpha. So this positive direction, 5 plus alpha to this one. Yeah, some random. So this is 2 pi 0. So this is negative in fact. So actually going forward, we draw like a straight line only. We draw I naught as this one. Because high inductance I'll use, and IS is something like this way. And this one I'll draw. I'll show that later anyway, going forward. So you can see here now. Now write a point here. Load current is continuous. Load current is continuous. And unidirectional. एक ही direction में ना. Load current is continuous and unidirectional. Okay. Whereas IS, source current, is alternating. Source current is alternating. Now with the RL freewheeling diode, that's what I'm saying here now. इसका voltage negative में जा रहे. Voltage negative में गया तो average voltage कम होगा. So what should I do here now? Yes, that's correct. Sahu, that's correct. So freewheeling diode use करेंगे क्योंकि freewheeling diode में negative output नहीं होना चाहिए. So ये वाला negative peak है ना, हमने already discuss कर दिया when the diode is there. Now it's just about SCR. So freewheeling diode, we get only positive voltage here now, no negative voltage here now. So a negative voltage नहीं है, लेकिन current तो continuous है. There is no change in the current. So let me show here now with the freewheeling diode. Just I'll draw one more picture here. So I'll show here now with the freewheeling diode. So we always use a freewheeling diode. That is very important for us because I want to make the average voltage more. Average voltage should be more. So here RL load with FT freewheeling diode, just drawing that. So same thing, only FT रखा. So V0. So what is happening here now? I'm talking about with freewheeling diode. With FT, I'm just writing here now. I'll talk about alpha 2 always. Please understand here now RL load. One thing, please make sure RL load plus FD is equivalent to resistance flow. RL load for V0. RL load FD is equivalent to R load. That's all. क्योंकि R load में negative voltage कभी नहीं आएगा. R load में negative voltage कभी नहीं आएगा. Only the V0 positive will be obtaining. So if I draw this point, freewheeling diode का action कब आएगा? Let us see here now with FD, T1, T2 on. What is the period? The period is omega T alpha to pi only. So pi to pi plus alpha. When the next SCR is triggered, T3, T4 trigger कर रहे हैं ना? कब करेगा T3, T4 trigger? So yet pi plus alpha. लेकिन ये पाई पे क्या चल रही है? जब आपने पाई आया, सोर्स वोल्टेज देखो नेगेटिव में जा रहा था, पाई में एक्सप्लेन कर दिया ऑलरेडी जब डायोड देखा है. So what will happen here now? When this become minus and plus, it was conducting there already at that time. So freewheeling diode is on. Pi 2, pi plus alpha, FD is on. So then what happens? I naught is going. ये वाला I naught है ना? Now ये वाला चालू हो गया, तो T1, T2 बंद हो जाएगा. T1, T2 off. T3, T4 I meant to give the signal, gate signal. Once the gate signal is given, current will be shifted to freewheeling diode से T3, T4 को shift हो जाएगा. So ये point लिख देना please. Please mention this point. With the freewheeling diode is connected, if a freewheeling diode is connected, yet to omega T equal to pi plus, yet to omega T equal to pi plus means just after the pi. Freewheeling diode is on. Freewheeling diode is on. And T1, T2 naturally commutated, naturally gets off. T1, T2 naturally gets off as the load current is going through the FD now. As the load current is going through FD now. Freewheeling diode. So ये वाला पीरियड में FD ऑन है, ये वाला पीरियड में T1, T2 ऑन है. Next one. Next what is happening? Pi plus alpha to 2 pi. Pi plus alpha to 2 pi. What is the on? At pi plus alpha, T3, T4 on. Okay. FD is off. Definitely FD is off. Next, FD is off. If you want to make this clear, FD off hoga. T1, T2 also off already. Then what will happen? Next one. Omega T is between 2 pi plus 2 pi to 2 pi plus alpha. That is 0 to omega T alpha. What will happen here now? T3, now FD is on again. FD on. T3, T4 off. Naturally gets off. So let me show these things here now. We already discussed this in diode mein. I'm just trying to draw their waveforms. So I draw the waveform here. V0 voltage waveform is improved. And the performance, we have seen advantages also. This is with FD. ये वाला VSI. I'm drawing V0 like a resistance one. I told you. This is alpha, either alpha I. So you just show here now. And this is only pi. pi alpha, pi plus alpha, 2 pi, 2 pi plus alpha. So like a resistance, no voltage 0 to alpha FD. When FD is on, V naught equal to 0. Same as a source voltage, pi takkai, pi to pi plus alpha, no voltage, pi plus alpha to 2 pi, 2 pi plus alpha, no voltage, and it's keep on going. Same as a R load. RL load with FD, I told you. RL load with FD is equivalent to R load as far as the V naught is concerned. R load में current continuous नहीं, इधर क्या current continuous है. There is no change in I naught. I naught waveform is same. Now RLE load, very important one. Same expression, same thing. E रखा है, RL and E, मतलब back EMF E, मतलब DC motor connect कर दिया. So what will happen here now? Let us see. Very important one. Same waveforms are same, but only thing is RLE is there. So let me do that. Shall I clear the screen? Shall I clear it? So RLE load में converter operation, inverter operation इसमें मिल जाएगा हमको. So all inverter operation के लिए I'd like to see this. I'm clearing it. Okay, fine. Nothing, waveforms are same. Single phase, we need not spend much time. Converter, RLE load. So whatever the waveforms are same as RL load, that's what I was saying. First point is waveforms same as RL load. So for this here now, what is the V naught? What we have obtained here now? RL load मैंने बता दिया RL load से. RL load में फॉर्मूला क्या है V naught के लिए? 2Vm by cos alpha. So 2Vm by cos alpha here now. In this case, alpha is less than 90. What will happen? V naught is positive. This is called as converter operation. If alpha is greater than 90, cos 90, say cos 100, cos 120 or cos 150, something like this, what will happen? V naught is negative here. This is inverter grade operator. Or I would say here now, line commutated inverter. So how would I write here now? For example, this is the one I was talking about. Vs, this is R, L, and E. Total voltage along this one is V0. So I0 is the current here now. So I can write also this one V0, which is equal to E0 plus I0 R. Because average voltage across the inductor is 0. So I can write this point V0, which is equal to E plus I0 R also. And of course, V0 is obtained as 2Vm by cos alpha. Okay. And we have seen the circuit turn off time. Circuit turn off time देखा हमने. Okay. Just copy that one. Sure, definitely. Actually, yeah, definitely. So you will look at here now. What I was saying here now, RLE loading. RL load matlab ये वाला very RLE load, very common load that we use. It is basically DC motor. DC motor में resistance होगा, मतलब high inductance रखेंगे, and then because it has winding, and E is a back EMF. We know back EMF equal ZP5N by 60A. ठीक है. So RLE load मैंने high inductance रखा तो current continuous है. E का बात कभी नहीं आएगा. Output में when you draw a kind of V0 here now, the same RL load, जो भी RL load में हमने draw कर रहे output waveforms. So this is how something you will be obtaining. These are the waveforms we are getting. So T1, T2, T1, T2, same as RL explanation. This is T3, T4 and T3, T4 here now. ये वाला waveform, ये E कभी नहीं आएगा. Output voltage में E आएगा only when the current is zero. When I0 zero हो गया तो क्या हो गया? All four ACRs are off. No current is here now. So V0 will be E. That is a discontinuous mode. वो वाला बात बाद में discuss करेंगे discontinuous वाला. ये assumption क्या है? Current is continuous. ये वाला current continuous हुआ तो continuously इसका circuit में जा रहे. So V0 will be, the waveform is something like this. So what I am doing here now, V0 मैंने average voltage निकाला 2M by cos alpha. Alpha less than 90 हुआ तो what will happen? Cos alpha positive, V0 positive. So look at here now, V0 positive, I0 is positive. This is I0 is always positive. So that's what I'm saying. Alpha less than 90, V0 positive. Mathematically देख लो. I0 वैसे भी positive है. I0 is always positive क्योंकि top to bottom. So the power will be V0 I0. So the power is coming from कहाँ से कहाँ आ रहा है? From power is coming from source to load. Do you agree with me? V0 positive है, current also positive, source to load power आ रहा है. converter mode of SCR. Alpha greater than 90 हुआ तो ओके अंचल अल्फा ग्रेटर देन 90 हुआ तो क्या होगा cos 100 यार सेकंड क्वाड्रेंट में मान लो 90 to 180 में cos थीटा है सेकंड क्वाड्रेंट में cos का फंक्शन नेगेटिव है तो V नॉट वैल्यू क्या होगा V नॉट will be negative. Do you understand this point? Do you understand this? Anchal, do you understand that V naught is negative over there? Cos theta second quadrant negative. So we are taking the alpha value between 90 to 180. तो क्या होगा V naught negative होगा लेकिन I naught क्या है I naught हमने ड्रॉ कर रहा है I naught continuous है look at the previous waveforms RL load में waveforms देखो I naught is positive so power क्या हो गया V naught into I naught this means negative. So what does it mean? Now the power is going when alpha is greater than 90. Now the power is going from load to source. अरे ये वाला कब possible है हमने कल डिस्कस कर दिया regenerative braking. This is only possible in the regenerative braking scenario. Regenerative braking में क्या हो रहा है you are giving the power feeding back the power from load DC motor to the source. That is a regenerative braking mode, which is called as inverter operation here now. Inverter operation में क्या होना चाहिए? Yes, definitely, current has to go back. So, which means that alpha greater than, I'm sorry, yeah, which means that total power has to go back, not the current. Total power is kind of going back. So this is called as a regenerative braking mode. Regenerative braking mode के conditions क्या है? क्या होना चाहिए? What should you do for regenerative braking? Yes, first one, alpha greater than 90. Another critical important point है V not negative होना चाहिए अरे ये V not negative कब होगा ये वाला इक्वेशन में अगर ये वाला इक्वेशन यूज कर दिया तो E माइनस लेना चाहिए so the expression that you need to take is V naught minus E I naught and R for regenerative braking for alpha greater than 90 otherwise क्या होगा एक तरफ मैं बोल रहा हूँ V naught negative करना चाहिए दूसरा टाइप अगर आप मान लो ये इक्वेशन को दोनों पॉजिटिव रखा तो V वैल्यू नेगेटिव कैसे होगा नहीं होगा इसलिए करना क्या अल्फा ग्रेटर देन 90 हुआ तो इस वाला इक्वेशन में आपका बैक ईएमएफ को नेगेटिव लेना चाहिए एंड डेफिनेटली दिस E voltage is greater than kind of V naught then only you'll get to this negative here 100 for example this one I'm saying minus 100 minus 10 plus 10 here so you get a minus 90 what does that mean here now don't you think E is more than V so we'll solve a problem here to understand better so this is what the inverter do you understand this inverter grade of operation so inverter grade operation में आपका condition के alpha greater than 90 रखना चाहिए मतलब it's our firing signal firing angle delay करो बस मतलब don't give 90 मतलब क्या होता है when should I give here now alpha is 90 means yes 90 के बाद say 100 degree then what will happen here V naught will be negative what basically what happened ये नीचे वाला waveform अभी देखो ये वाला waveform ज्यादा पॉजिटिव है कम नेगेटिव है इसमें V naught पॉजिटिव है overall when you take the alpha greater than 90 what will happen नीचे waveform जो भी नीचे waveform that is ज्यादा होगा so overall V naught negative होगा you understand that point अंचल समझिए ये बात मैं क्या बोल रहा हूँ
Yes, sir.
okay fine good so we'll see one problem here because there are problems great problems here now converter and inverter grade operation that is only possible here now RLE load होना चाहिए if E load is not there back EMF is not there or battery is not there your regenerative braking is not possible or inverter grade operation is not possible yes V naught can be negative but a source power is going from load to source is not possible when E is not there I hope you understand that point and let me see a problem to understand this better Of course, we have a gate problems also on RL load. Yeah, let us solve one problem. You'll understand better. So I want to calculate the firing angle delay for converter and inverter operation. RLE load है, bridge converter दिया. इधर देखो RLE load, bridge, VS voltage. VS voltage, it means RMS voltage. I naught is DC voltage, RL is given. So what is that given? VS equal to 230. So VM क्या होगा? 230 into root 2. VM by root 2 is VS RMS value. I naught is given. DC is 10 amps continuous and R is 0.4 2 millihenry. E is 120 volts. So then what is that? I need to firing angle. Na? So what is the formula here now? Let me show the picture then so that you'll get something. V0. So I told you already I have given V0 which is equal to I naught R plus E. This is for converter. And V0 value, what is this is 2 Vm by cos alpha. We already calculated. I naught R E. So 2 into 230 into root 2 by pi. Pi means here 3.14 लेना चाहिए. Cos alpha, I don't know. Cos alpha calculate करना. I naught is 10, R is 0.4, E का value 120. So alpha calculate करना पड़ेगा. Take this 3.14, find the value of alpha. This is the first one. Second case में इन्वर्टर ऑपरेशन है. इन्वर्टर ऑपरेशन में क्या है? इक्वेशन तो वही है, I naught R. I told you you have to take this as a minus. So E has to be taken minus 2Vm by cos alpha 10 into 0.4. So otherwise you can keep it here itself. Minus for inverter gave. That's a critical point. Minus 120. Substitute here now. Find the alpha value. ये वाला alpha less than 90 आना चाहिए. ये वाला alpha greater than 90 आना चाहिए. Okay. What is the value? First one it seems. So somebody replied. Anjali, yeah, first one is 53, that's correct. And the second one is around 124 around. Just verify this. Okay. Yeah, since you have doubt about inverter mode operation, please write some notes on inverter mode operation. Keep the heading like inverter mode operation. First point. If load circuit EMF, or if E is negative and alpha is greater than 90, If E is negative and alpha is greater than 90, then the source E will feed power back to AC source. The source E will feed power back to AC source. Second point, if alpha greater than 90, average output voltage is negative. Average output voltage is negative. Current is positive. Current is positive. The net power flows from DC load to AC source. DC load to AC source. This operation is known as line commutated inverter. This operation is known as line commutated inverter. Next point. In converter operation, average output voltage must be greater than load circuit EMF E. Average output voltage must be greater than load circuit EMF E. During inverter operation, load circuit EMF must be more than AC supply voltage. EMF must be more than AC supply voltage. So there are some performance parameters we need to define here now. That's about the regenerative braking or inverter mode operation. We'll see some performance metrics. So what is happening here now in the single phase full converter as far the source current is concerned. So we'll see here now. See the IS waveform. Full converter. Current is continuous. You take R load, RLE load, whatever it may be. Continuous होने के लिए आप RL inductor should be very high. So we have seen that source current is, this is how the source current. हमने source current draw कर दिया है. So you take I naught is constant, IS is constant, I naught is constant. I naught constant हुआ तो what will happen IS then? IS is 0 to alpha here. Do you understand this? We have drawn, look at the IS waveform. Only thing is I have shown like this. IS का waveform मैंने something like I have shown here now, increasing, decreasing, but now I'm making as a kind of constant because I not constant. So then IS will be waveform like this. So what will happen here? Do you understand the context of this one, guys? This is alpha. Do you understand this? Pi plus alpha, 2 pi plus alpha. This is how the source current. Source current, and this is what I am drawing. So this is I naught. I naught is always constant. Source current means this is the one. ये वाला waveform. इसका waveform draw कर रहा हूँ मैं. When 1 and 2 conducting, left to right में जाएगा. When 3 and 4 are conducting, right to left में जाएगा. So alternating है. So now Fourier series. How can you write this one? IS of t Fourier series, if you write it, A naught plus sigma 1 to infinite an cos n omega t. This is important, boss, please. Plus bn sin n omega t. Otherwise, this can be written as, this is a generalized formula. This can be written as I naught sigma 1 to infinite Cn sin n omega t plus theta naught. For mathematics, you might have seen in the Fourier series expansion. So where Cn is square root of an square bn square, you know the values of a and bn, that is 1 by pi integral 0 to 2 pi. What is an here now? Let me write it here. Mathematics में आप लिखा होगा IS. Zero to 2 pi source current. And your I naught is a DC value. We know this. What is I naught or A naught? A naught value is 1 by 2 pi 0 to 2 pi IS. This can be written as 1 by, in this case, so A naught, let me write 1 by 2 pi 0 to 2 pi IS d omega t. IS d omega t average value, this is 0 in fact, that's a C naught value or I naught. So if we finish this Fourier series, ये वाला अगर आपने कैलकुलेट कर दिया मैथमेटिकली, आई नो द वैल्यूज, ये वाला याद रखना प्लीज, बिकॉज देयर आर मेनी गेट क्वेश्चंस ऑन दिस. It is to try to remember. IS source current is sigma n, of course only odd will exist, 135 4 I naught by n pi n alpha. This is the IS value, total ISF or IS of t, whatever it may be. N to infinite 4 I naught by n pi, Cn value, that is Cn value, sin n omega t, theta n value. This is what we are obtaining is theta n equal to minus alpha. From here now, what is the RMS value? I can calculate the RMS value of the fundamental. So if you write the completely, if you expand it, 4 I naught by pi, 1 substitute karna, n equal to 1, omega t minus alpha, then 3, 4 I naught by 3 pi, sine 3 omega t, 3 alpha, and so on. It will go. This is called as a, this one, ye wala component. This is called as fundamental current. Fundamental instantaneous. This one is called as a, and so plus, it will keep on going. This is called as a third harmonic current. ये वाला third harmonic current. So ये वाला instantaneous है, which is IS1. So if you write the IS1, मतलब fundamental component का नहीं तो first harmonic का RMS voltage. What is this here? We IM by root 2. So 4 I naught by pi, 1 by root 2 is the IS1. This is, what is this IS1? This is RMS value. RMS value of fundamental current. IS1 is RMS value of the fundamental current. Okay. Now, what is IS? Total component. This is IS, है ना? इसका total RMS value चाहिए. What is average value for this? What is average value for this? Average is 0. कितना positive है उतना negative है. So average value is 0. But what about RMS? How do we calculate RMS of this one? We know 1 by time period and those things you can have it. What is the time period of this? So you can see here now. Under root of 1 by time period is pi, and alpha 2 pi plus alpha, you can have it. What is the magnitude here? This is the magnitude. Magnitude is I naught. I naught square d omega t. To substitute here now, I naught square pi minus alpha and pi get cancels out. So you are remaining with I naught. Your RMS value of total one is IS. Now the actual terminologies will start. Very important one. So fundamental RMS current calculate कर दिया, and total RMS value calculate कर दिया source के लिए, source waveform में. तो क्या है, दिक्कत क्या है? So I'm going to explain what are the disadvantage of the PE devices. What makes the PE devices creating problems? Although we have more advantages, the disadvantage of the PE devices is this is a common point for all 4 electronic devices, is it adds the harmonics on the source side. Load side ठीक है यार, source side में, load side में भी some performance metrics देखना है. Source side में harmonics आया. Current is alternating with a rectangular waveform. Look at here now. Sine waveform आना चाहिए, नहीं तो हमको sine waveform नहीं आ रही इधर. इससे पहले sine waveform था. जब हमारा लोड कनेक्ट कर दिया, अगर PE डिवाइस नहीं तो फोर्स करंट इज अ साइन वेव फॉर्म, लेकिन अभी क्या हो रहा है, नाउ रेक्टेंगुलर वेव फॉर्म आ गया। सो परफॉर्मेंस मैट्रिक्स क्या डिफाइन करना है? हेलो। Sorry, yeah, some call, other call. So what I was saying here now, very important expressions. Anyway, tomorrow also will continue on this. First, I would like to mention this current distortion factor, some terminologies. Current distortion factor, CDF, which is called as CDF, defined as IS 1 by IS. Very important one expressions because गेट में पूछा है IS 1 का वैल्यू कितना है? What is this IS 1? IS 1 is this and IS is this 4 I naught by pi 1 by root 2 upon IS is I naught. So this one 4 by pi root 2. Second one, displacement factor. Very important, DF, which is equal to cos theta 1. In this case, theta 1 equal to alpha. So cos alpha. Alpha is firing angle. Now this is what asked in examination, power factor. Power factor is CDF into DF. Distortion factor and displacement factor multiplication. So this becomes, by the way, what is this one? This value will be around 0.9. So CDF is 0.9. 0.9 into cos alpha is the power factor. So the power factor is of the source power factor, in fact. Another one, it is done anyway. One more, total harmonic distortion. So source side में harmonics होगा, fundamental, first, third, fifth, and so and so. Then what is the total harmonic content? That is third, fourth, fifth, and so and so with respect to the fundamental one. Is harmonic factor, third, fourth one. HF, or this is called total harmonic distortion, THD. So this is defined as square root of 1 by CDF square minus 1. And अगर ये वाला substitute कर दिया, CDF value पता है हमको 0.9. This value will be 0.48, 0.483. That is 48.3%. This is also being asked in exam. Total harmonic distortion. How much harmonics, percentage of harmonics are existing on source side as far as the current is concerned. Okay. Basically, how do we obtain this? this one, total harmonic content, that's what I'm saying here now, THD square root of, this is basically how much component, what is the total harmonic component means, IS by IS1 square minus 1. I know IS1 by IS, मतलब total source current IS में पूरा harmonics होगा, इसमें fundamental का कितना होगा, ठीक है? That's what we are doing. So 1 by CDF square minus 1. Or rather, I would say here now, this can be written as, to understand more, THD को कैसे लिख सकते हैं? IS square minus IS1 square. IS में 1 होगा, 3 होगा, 5 होगा, 7 होगा, कंटिन्यूसली हो जाएगा. उसमें फंडामेंटल सब्ट्रैक्ट करो. With respect to fundamental, how much percentage? So that's what we are obtaining here now. Under root of IS by IS1 square whole square minus 1. That's what IS1 by IS is CDF. So CDF substitute करते. So this is how we'll be doing the things. Okay. Okay, then I'll stop for the day and tomorrow we can continue. Okay. Okay then. Thank you guys. See you tomorrow. Thank you, Bhaskar. Thank you guys, Anchal and others. Yeah, thanks.